Welcome to Vision to Venture. I'm Eddie, and I'm here to uncover the realities of scaling and building a tech startup. Each week, I speak to leaders within the tech space with their insights and advice on how to found, fund, and frame a tech startup. So make sure to follow and subscribe to never miss an episode. Hello, and welcome to today's episode of Vision to Venture. Today, we are joined by Ashish Jha, an expert in the field of machine learning and AI, whose work has spanned industries from finance to construction. Ashish is also the author of several books, including Fight Fraud with Machine Learning, Mastering PyTorch, and the Supervised Learning Workshop. Hello, Ashish. How are you doing today?
Hi, Eddie. Thank you so much for having me.
Thanks for joining.
Very excited to speak with you.
Likewise, yeah, pleasure to have you on the pod. I'm really excited to get started. And without further ado, I'd just like to start off with your time at Tractable. You worked on an AI pipeline for car insurance claims fraud detection. What were some of the biggest challenges that you faced integrating both tabular data and visual classifier features?
Yeah, sure. Tractable is doing very well now. Like it's a unicorn. Last time I checked, it's been like 4 or 5 years. So let me recollect. So basically, the mission of this company has been to really use AI to automate car accident insurance, claims process, which is quite tedious. As I learned when I entered the company, what I was working on back in the day was, as you said, claims fraud detection. So what happens is someone has a car accident, unfortunately, and then they give the car to the body shop. The body shop experts provide an estimate of how much work needs to be done, what needs to be repaired, what needs to be replaced, and this body shop estimate goes to the insurance company. They approve it, and then they dispense the sum of money. Apparently, body shops do a lot of fraud in that estimation because they can, because it's difficult to kind of check how much of the prices are inflated, either for the labor hours or for the price of the parts. That's where my model was trying to come in and do the fraud detection. So if you think about it, it kind of involves the estimate data, which basically looked like a lot of like CSVs. So that's where the tabular data comes in, but it also had a lot of basically car images, because you also need to see. So if you were the insurance company trying to catch the bullshit from the body shop estimate, you would want to see the extent of damage. And this is where we built a model that looks at visual features and tabular data. Now the challenge in bringing these two worlds together, as you can imagine, is CSVs look very different to images. We look at an image, something happens in our head, we can understand what that image means. We do not need to be told what each pixel means individually. But in CSVs, you have columns with their names and their meanings. So what we ended up doing was bringing these two worlds together by numerical features of the images combined with the tabular data. The numerical features are essentially called embeddings. It's quite a popular term now in machine learning and AI community, which is you take this natural piece of data, could be text, could be images, could be voice. You pass that through a model and convert that to a vector of numbers. The biggest challenge we faced when we combined these two sources of information and trained a fraud detection model was when you want to update the system, you can't just update one. So you can't just update the visual model, but retain the old tabular model, because these two worlds speak different languages. It's a bit like biscuits go well with tea, but not really so well with lemonade. Maybe I'm wrong, but you need to maybe have something else with the lemonade. So you need to update both. So what we did as a solution was to have coupled retraining. So whenever we had to retrain one model, we had a training job which would trigger the entire retraining process, because it was a stacking approach combining these two worlds. Another challenge we had was interpretability. So it's easier to interpret tabular models because they have something called feature importances. So if you had a tabular model predicting house prices, The feature importances might look like the most important feature is the area of land the house captures, the neighborhood house is located in. But for visual features, it's very difficult because embeddings have abstract numbers. And so what we did there was we individually, atomically interpreted the visual model in itself. So there was a visual model which took car pictures and located with bounding boxes where the damage has happened in the car. And we used that model to understand, to interpret where the activations are happening. Is it really learning the damage areas, or is it just managing to, bullshit through and giving a high accuracy? So, interpretability and updating models, I would say, were the two biggest challenges that we faced.
And going through your entire career,
Yeah,
at Revolut, you developed machine learning models for KYC and fraud detection, and Revolut's scale is immense, with obviously over 40,000 clients onboarded daily. How did you ensure that the machine learning models you deployed could handle this scale efficiently and accurately?
yeah, that has been a great accomplishment. So, proud to say that I deployed the first GPU inference model at Revolut. It
Mm-hmm.
was a transformer based model. Transformer is the architecture that powers most of today's LLMs. This was meant to extract information from ID documents such as passports or driving licenses.
Mm-hmm.
This was like a 440 million parameters model. Not that huge, but this was already 2 years ago. And we were supposed to deploy this to, as you said, serve 40,000 customers a day and at less than 1 second latency, which means it should return the results in less than 1 second in the worst case. So to do so, basically we had to perform a lot of optimizations. Obviously, they happen in stages. So one is the stage of software layer where you train this model, uh, going from ID document photo to all of the information extracted. You train this in PyTorch or TensorFlow, which are the two main deep learning frameworks. Now they might not be fully optimized for speed and performance. They are more geared towards giving you high accuracy results. So then you can use optimized runtimes like ONNX runtime, OpenVINO. I think we used ONNX runtime in this case. So you convert this model into this specific optimized runtime. And what happens here is every deep learning model essentially is a graph of mathematical operations. And these runtimes kind of look at the entire graph and try to find any reductions that is possible without impacting the overall mathematical equation going from the input to the output. So that's the that's the high level of optimization that can happen. It includes a lot of other things like reducing the precision of floating point numbers when it doesn't really impact the performance so much. So we did all of that. We converted PyTorch model into ONNX format, used ONNX runtime to run the inference. We did stress testing on like 50 requests per second being the peak throughput at peak traffic times, and managed to get less than 1 second latency. So that was good enough for us to go. But not just the software layer, but also the hardware layer, where we could not just do away with CPUs. We also needed to use GPUs for inference, which is like everyone knows GPUs now. Nvidia being the biggest company ever so far because of GPUs alone. So GPUs for running inference also played a critical role. And I would say, in general, to really deploy models that can perform well, it also goes back to your R&D phase of the project, where you really have to make sure you use the smallest model that can do the job for you. So many AI folks tend to use the most sophisticated model that they can use, but many a times you can just do away with a small model, the smallest image or video resolution. So you might not want to process a 108p video, 1080 pixel video, but you might just get enough things done with a 144p equivalent. And like, also at the highest abstraction of, you have the business goal, you want to build an insurance claims fraud detection model,
Mm-hmm.
does not mean that you have to translate that to the most sophisticated technical task. It can be much, sometimes you don't even need ML, to be honest. So those are the things I would say, those are the optimizations you need to keep in mind, especially when you are hitting a huge scale as Revolut was hitting and is still hitting right now.
Sounds like a lot that you've done at these very big companies, isn't it? Um,
Thank you.
no, it sounds very, very impressive as well. Especially as that was like quite early on in your career, obviously, and everything that you've achieved since then as well. Um, so now, as the head of machine learning and AI at XYZ Reality, um, you're working on an MR platform. What unique challenges do you face in applying machine learning to mixed reality, especially in the construction industry?
Ah, so you're bringing together the AR and the construction. So, firstly, just for AR, augmented reality headsets are still a new thing. I would say they have been coming since the last decade, but it's still to take off. Like Apple Vision Pro, maybe thousands of them were sold, but not really millions. So the thing is, data that is available today is more coming from mobile devices or camera or like things that have been mainstream, everything except AR headsets. So first thing is that data sets for AR is rare to come, especially from now. If I bring construction into play, it's even more rare to have construction AR headset data sets. So it's difficult for like for us to use some public data set, so you have to build your own right now. That's such a niche that we are working on basically, because everything in AI begins with data. If you don't have the correct data, you it's just garbage in, garbage out, otherwise. And then secondly, when it comes to deploying models in AR, so there are frameworks like Unity, that where you build your holograms and all of the stuff that you want to show in those inside those headsets. The model deployment also needs to happen inside Unity. So Unity has involved, for example, it has Unity Sentis, and by the way, there are other platforms, Unreal being another one, um, that allow you to build applications, but you have that confinement of that platform. You have to build things inside, as opposed to at Revolut, for example, you build your platform in Python ecosystem. You deploy that as a microservice, which is very common as a web service. So yeah, that's another like constraining impact because we are in the AR industry. And then you are building things for the headset. Imagine how do you test that? So testing through an emulator can only take you so far. A
Mhm.
mobile app, when you're developing, you can really test all of it on an emulator. You don't need to have an iPhone 16 to build an app for iPhone 16,
Did not know that.
because you can just emulate anything basically, like the entire flow of it, right? Unless your app needs a lot of movement on the phone and so on.
Okay.
But with AR headsets, that's always the case, that you have to test it with the headset around you, get a feel, and so on.
Just to make sure it sort of works specifically for that product in the
Exactly.
way that
Because
you want it to.
yeah, because it's so immersive, you want to test that whatever you have built is really gelling in well with the entire immersive experience. So if I build suddenly a face detection module on AR headsets, I'm looking around
Mhm.
and it shows me boxes of on top of the faces. What if I'm looking at people, that module works, but it's so laggy that I have already moved on and the box is now displaying over there.
Well, and
So
that would happen if it's not well. I guess
it's
it's
it's too slow. It doesn't have the same impact. So even if your model is working, you lost that immersive experience. Which brings me to one of the key, like, I will just finish wrap up with this, which is latency has a different meaning altogether inside AR, because unlike, like on websites, sometimes things are laggy a bit. It is still not having that kind of a disturbing experience to you. You know that something has lagged for a bit, like, okay, it's not ideal, but it doesn't completely distort your view. But if you are in that world, virtual world or
you
augmented
don't
world,
want it laggy.
yes, any lag kind of throws you off, because once you put these headsets on, what you're seeing in front of you is not the real thing from your eye. It's actually the rendering of what is out there into your eyes from these lenses. So if something is distorted, it really messes in your head. So
I
you
think I'd
want
get feel like seasick if that happened to me.
it actually can have that impact. So that's why it's a lot more rigorous testing. We have to be
Yeah.
really sure about making those like smooth transitions between frames. So what happens is, if you have a machine learning model which is slow, you have to do some clever stuff around inter splicing between frames. So like, you are going from here to here, I have to predict that because you're moving like this, even though I don't have my predictions ready at that frame, I will delay that prediction over to the movement and like predict that I'll show you you the frame over there.
Yeah.
So all of that smart stuff has to be done, which is not the requirement in typical ML deployment on web apps or on mobile apps.
So, how do you see machine learning transforming the construction industry in the next 5 years? And what role do you envision XYZ reality playing in that transformation?
Yeah, I mean, yeah, we just discussed about AR a lot, but like in construction, there is not just AR stuff that needs to be done. Construction industry, firstly, is like far behind. Sadly, it's a fact that like maybe agriculture, construction, these are like industries which are really really far behind when it comes to adopting today's technology. I'm not talking about using hardware. They use quite cutting edge hardware when it comes to on site usage of machines and so on, but they do not use the information technology of today. So that's the starting point, and I like to believe we are living in this like AI like revolution, so to speak. In the last 5-10 years, it's just gone massive.
Hmm.
So AI will have a leapfrogging effect on construction. What do I mean by that? So I come originally from India. In the West, the phones, they had this smooth transition from the wired telephones. Well, first you have to have those like the things that you had to pull all the way clockwise to ring in the numbers, and
Oh.
then the buttons, still wired, then the cordless,
Yeah.
more stuff, then the early shitty mobile phones, and now the smartphones. You know what happened in India? Most people just went straight from wired phones to smartphones because
Big jump.
it became ubiquitous. So that's the leapfrogging effect. So what I'm trying to say is construction might not have to go through no information technology disruption to web uh, web apps, and then to mobile apps, and then to AI. It might straight up go to AI powered technology being ingrained, so which is what is happening. I think XYZ is playing a huge role in that as well. So yeah, that's one thing which is it's far behind, and it needs a lot of catching up to do, which is happening right now.
Yeah.
So I imagine, so we have seen LLMs coming about for almost any industry. Like we have legal language models that can talk to you all legal stuff. You have medical LLMs which can understand all the medical terms and give you like understand all the medical reports and so on. I have not yet seen a good construction LLM. I am already in that game myself inside XYZ to build one, but I think that has to come at some point. And where I'm coming from is construction has its own vocabulary. In a construction, just to give a broad picture, you have something called a building information model. So it's like the 3D model of what you need to build, which is done before anything starts. And then there is a schedule, which is like the it's like the itinerary you make when you go for your trip to Thailand. So it's like the steps that you need to perform to build the entire thing out. These two pieces of information are written in the most old proprietary softwares, and there is a huge gap between how it's in a closed source format right now and how AI is ready to take all of that in and like just basically be able to understand everything. Is the next thing is you can ask it, given all of this information, can you tell me which what do I need, which ingredients do I need to perform step numbers 117, and it should be able to pull back all the information and so on. So that's one. I think AI is gonna help with a lot of construction things that are not possible now. Everything is manual in construction, so it'll help with forecasting delays. We all know construction ubiquitously everywhere in the world is always late. It's one common thing we can all share together. So it might help forecast delays, make it more data driven, like what is going wrong, can we fix that, and suggest some actions like proactively based on all of the learning it can do. So, and bringing it to XYZ, the aim of the company is to build from holograms. It's like a game. Ideally you just put on the hard hat, you see the entire 3D structure in front of you. All you need to do is you fill that up with the concrete and all of the underlying materials. So that's a goal using the AR headsets. And we have already talked about how AR is like coming along in this recent AI advancements as well. And we like at XYZ really want to become that intelligence engine. Besides being the AR hard hat provider, we want to become that intelligence engine that a builder can basically use to understand their projects like inside out, what's happening at the finest level to the highest level. And hopefully this hard hat that we have becomes like the default construction helmet, because today's construction helmets are just plastic fiber. If they put on this instead, they basically can 10x their both speed and quality of construction work. So that's where I think we are heading at.
It's a lot to it, isn't it? There's a lot of there's a lot of different things that need to happen by the sounds of it. And it's like, as you were saying, it's like um went from obviously like the cordless phones and then all the smaller phones, and it went up and up and up, and everything's evolved so much.
Yeah.
From where it's obviously completely different for you, because it's like from where I'm standing and from my point of view, obviously where I'm not in the thick of it. I don't now I'm like, oh, it's just there's not much changing. It's just like
Yeah.
check is just like all the tech stuff is just on like this like very steady like shallow flow upwards. But it sounds like it's not at all. It sounds like it's just a lot is happening.
Yeah, it's quiet,
Um
it's a quiet waves until it's not, until you have a
yeah, and then
decision.
just boom,
Yeah.
just yeah, shoots up, which is crazy. It's crazy to me. Um so you have published not one, not two, but three books. Firstly, what inspired you to start writing in the first place? Like, where did you get that inspiration from?
uh, this might be like a very, like off-putting answer in the sense that it's like so anticlimactic. It's actually nothing fancy. I always myself looked at writing books as such a daunting task and such an impressive piece of work myself. So I was new in London 5.5 years ago. Tractable was my first job. And one fine day, I still remember that evening, I was sitting right across the CTO, late evening, and got a LinkedIn message. Hey, would you want to co-author a second edition of a book called The Supervised Learning Workshop? And I was just like, yeah, I was like, is this real? Like, do I really get to write something in a book? And I was like, why not? Pursued that with Pact, the publisher, and so went through the whole process. Firstly, that disillusionment happens when you realize it's just another piece of work like any other piece of work, but it was really rigorous. And one thing I really loved in that process, I hadn't written anything of that kind before, like for the last 5 years before that. That made me go back to my fundamentals of machine learning, of supervised learning. And when I ended up writing everything, I had a laser focus on my understanding of the fundamentals. It really helped me in my job as well, and it also kind of gave me my voice of how I want to communicate my ideas. Like writing is really underrated. Like you should write, journal your things, your thoughts out. So it really gave me that positive reinforcement that I should go for another one. So I reached out Pact a few months after this book went out. Hey, I want to write a book on deep learning, and my personal idea was I just want to write a book that bridges the gap between, oh, deep learning is so fancy and so difficult and mathematically so daunting. I wanted to make it more simple, so that was my idea. And then they had this other idea coming along. Hey, we need to write a book on mastering PyTorch. And PyTorch has been, now is clearly the winner. Like it's the mainstream deep learning framework. So I was like, it kind of aligns with my thoughts as well, so let me give this a shot. So I wrote this book with that idea coming together with PyTorch. And yeah, that was really like fabulous. It really helped me again. This was the first edition completely by myself. I think the first edition had 14 chapters, so a lot of work, and it broadened my understanding of ML like it would never do in a regular job. And so that was a story of mastering PyTorch. And then, having worked at Revolut for 4.5 years, and most of the time spent in the fin crime department working building anti fraud detection or KYC automation models, I really felt inspired to maybe write a third one called Fight Fraud with Machine Learning, which is almost going to be finished. Maybe it is finished by the time this goes out. So yeah, I mean, it has been like a really process. It started very vanilla, and then it just grew on me. I always have felt like an imposter. I always question myself, like, do I know anything? And then writing books really helped me to feel more authentic about myself, that I know the subject I am
Yeah,
claiming to be an expert
come
in.
out of your brain.
Yeah, it's like a great outlet to, like, just trying to simplify complex stuff. And you have the benefit, like, working with publishers to get their feedback, the editorial reviews, and so on. So yeah, I mean, overall, I'm really glad I took this course of action.
Absolutely. And your most recent book, Fight Fraud with Machine Learning,
Yeah.
how do you see this book contributing to the fight against online fraud?
Yeah, so, like, fraud is a massive industry, unfortunately. And I think it's only growing because the world is like, we all know, like, we are moving from living in the real life more to living in the digital realm. I think
Yeah, and they're getting better.
they are getting better, and
They're getting better.
AR and VR is only going to make us go more digital, like more away from the real life. So in real life, things are real, so you can catch bullshit. You can It's easier to detect fraud, right? If someone is behaving shady next to you outside a tube station, you know to keep out, right? But in the digital world, look, man, like, today people are actually creating fake videos of someone, like your family members, in a video telling you, I desperately need some money because I have lost my car, and their voice matches, their face matches. And to that level, like, so many people are so like, gullible, at least technologically, that they will fall for all of this. So yeah, I mean, that has been a huge like, massive motivation for me, that we need to talk about this more. And whenever you want to write a book, you have to give like an initial bundle of, like, firstly your idea and your research on what has been done on this before. And I encourage you and whoever watches this to go and go and seek a comprehensive resource on fraud detection which covers today's cutting edge AI. I didn't find any. If I found one, honestly, I wouldn't bother just repeating all of that in another book. But that was a motivation for me to put together all of that information in one place, because you can sure find some blogs scattered here and there, but no one is really giving out that knowledge. And instead, there are companies working on solutions, but it's all closed source. So that inspired me to build this bridge for that gap. Who is going to use this? So if you think about so many tech products that are coming out, right? Fraud applies for so many of these. It can be for fintechs like Revolut, Monzo, Klarna. It can be for e-commerce websites. People do a lot of fraud over e-commerce as well. Social networks, so bots, they can do all kinds of harms, as you might have seen in the news. Insurance, and so on. So anyone who is building a tech product in many such spaces should be factoring in fraud detection early on, rather than that being an afterthought that it usually is. Because when you get burnt once, then only you realize, okay, I need to watch out. So I think that's my motivation. That's my idea behind writing this, getting this out, and laying down some frameworks. Again, this is like a very hands-on book. So anyone who gets their hands on this book will be able to easily digest information. It's always been my theme to not write any mathematical equations, any daunting stuff, but go straight to the point.
After all you saying all that, I wish I had a bit more knowledge around fraud because then I feel like I would have, I'd spot it easier before I get money stolen from me. But hopefully, there'll be people like you that are going to help people like me not have money stolen. So moving on to your next book. So with PyTorch becoming such a popular tool in the deep learning community, what unique insights or techniques do you offer in your book, Mastering PyTorch, that you think are essential for practitioners today?
Sure. So first thing is, like, most of people working in tech today, very few are working in the academic pursuit of like writing research papers and going full on into research. Majority are working on applied stuff, so they are wanting to use what is available and apply in real life problems and build real life products. So to that, the book is fully hands on. Each chapter comes with some coding exercises, so it feels like you are learning with every chapter something new, and there's an instant feedback loop within a chapter. It's not like you're just consuming stuff which hopefully will be useful in another place. And this within PyTorch, right? PyTorch is a great library, but it's also a great ecosystem of libraries, including PyTorch Lightning, PyTorch Geometric, Captum for interpretability, but also Hugging Face. Hugging Face is like it's so popular. I don't even need to explain what it is. It's almost like the town square of AI. I like to call it. So I also talk a lot about Hugging Face integration with PyTorch. These are the things which again is available to be read on the internet in different blogs here and there, but there is no comprehensive resource to talk about all of this. And then going to the fundamentals of machine learning AI, I talk a lot about ML ops using PyTorch. So all the way from distributed training on CPUs, GPUs, with all those techniques such as mixed precision training and so on, all the way to actually also deploying models using Torch script, using ONNX runtime on a C++ language base, or like maybe on an embedded device, or even on mobile apps, so on iOS or Android apps. So that's again giving a very comprehensive MLOps view using PyTorch. Again, I don't think there are so many resources available which cover everything and this together. And then there is a lot of fun apps like neural style transfer. So there is a chapter which brings in a Picasso like painting together with a photograph of Taj Mahal and makes it look
Oh,
like
wow.
Picasso, how he would paint Taj Mahal in his
That's
style.
really cool.
Yeah, so you learn to do. It's like a fun way of learning the language, learning deep learning, but also ending up with building something cool that you can maybe change those two images to something else of your liking. And then there is AI musician. So there is an AI model that you build that can play like Mozart would play, and then you can replace Mozart's data with someone else's, and then you build your own stuff.
Oh my God, wow. That's
Text
very
gen
cool.
Yeah, like there is a chapter on generating anime images using diffusion. So I'm sure you might have heard of stable diffusion or
Mhm.
all of these like
It's
I forget.
everywhere.
Yeah, all of these like amazing image generation models that have come around. So yeah, there is a chapter to explain how it all works, but also you end up generating those images so you feel good, I hope. So yeah, this basically book is trying to cover a lot of ground, keeping it all hands on, removing all the daunting mathematical stuff, keeping everything in code. And yeah, I think the value proposition I think is in everything being together in one place, which is the difficult part. If you are so motivated, you would go and find different pieces, different places. But if you had this resource together in one place, I think that's where the value is.
So if there's so much happening in we're like within PyTorch and so much to learn, how do you see PyTorch evolving, and what do you think what should developers and data scientists be prepared for in the coming years?
Yeah, so besides PyTorch, TensorFlow is another huge library from Google, right?
Hmm.
I think one aspect in which PyTorch has always been ahead of TensorFlow is its research base. So researchers mostly use PyTorch whenever they're writing research papers, be it from Stanford, MIT, or be it from Google Research, Facebook AI Research. I expect the next transformer likely to be built on PyTorch. So transformers is the current everything, but there has to be a architectural disruption, and so watch out for maybe that to be built on PyTorch. So it's good if you have a grasp of the language or the library, so you'll be able to better deal with that. And I don't know if you have noticed, PyTorch has become part of the Linux Foundation. So there are so many contributors now. I mean, companies contributing to it: NVIDIA, Intel, Amazon, Meta, of course, the parent contributor. So I think PyTorch is now getting more and more cross-platform features, especially on the deployment MLOps side. so it's becoming more pervasive across different environments. So that's another thing to look at, because I think AI is really, like, when the time when we are recording this, we are living through that exponential phase, like that, like the crazy growth phase. Different companies are coming up with more and more advanced AI stuff. Like, it can be in different dimensions, and PyTorch is inside many of those advanced stuff. So Nvidia is bringing its own suite of LLM stuff, for example, and it's all written in PyTorch. So um, I think that is something we should expect more of in the coming months and maybe coming years. And so again, having a good grasp of PyTorch would be helpful. I'd like to also say, and this is again, it sounds spooky, but coding actually might be dead in a few years. We might not be coding much. It is actually, I increasingly feel that to be the case. So English, as Andre Karpathy said, English would be the is the latest programming language. So English might just be the language that we say as developers, and then the LLMs or the AI does the job for you. In that world, knowing PyTorch would be similar to maybe knowing, the under the hood Linux kernel stuff. Like, everyone takes all of this, like Mac, Windows, or Linux programs for granted. Very few people know how they have been programmed, like those things have been programmed. So there are experts who know the inside, like under the hood details of operating system stuff. I think soon, like in 5 years especially, PyTorch will become that level of detail where only few would know, and most new people. So I'm saying this at the risk of knowing that I have written a book on PyTorch, but I am also seeing that in 2 to 3 years, it might become so far down in the details that people will just be dealing in English or in their native languages.
So it could develop quite a lot then.
Yeah, you would
In
earn
the
a
next
lot
few
if you
years.
still knew PyTorch because you
Yeah.
would be able to do things which most people wouldn't. Yeah.
Wow. And so the final book that we haven't spoken about, the Supervised Learning Workshop, it takes an interactive approach to learning. So why did you choose this format, and how do you think it benefits readers compared to like traditional textbooks?
Yeah, so traditional textbooks, right? I don't know if you remember any of your traditional textbooks.
Yeah, I hated them.
So in my case, like, I was studying machine learning in 2014, had so many textbooks around it, and one thing I always found daunting was again those mathematical equations, and like just lots of theory, also boring, right? Today I can't even imagine today's students with such short attention span. I can't believe that they are reading like 400, 500 long theory books on stuff. So I anyway found them to be too daunting and dry, to be honest. And as I said, like, large part of AI workforce is working on applied AI. So that is where this intuition came from back then, that I really like the format where first the information is really presented in simple words, and then whatever theory I'm saying is immediately complemented with some relevant code snippets that the reader can immediately go and run on Python notebooks, so that they immediately complete that feedback loop, the learning loop, and they do not feel like I just have to keep reading through until I go somewhere and then and try these things out. As a student, basically, I wished for some such digestible material back in the day. I didn't see much. Today's students are damn lucky, they have everything in their hands. They might just be learning from ChatGPT straight up now, I don't know. So yeah, that was the motivation for me to write very interactive and like very hands-on book.
It sounds like a nice way to like change things up. But no, it's really, really good to see. Really nice to see and hear that you've done that. And just finally, wrapping up this podcast,
But
what advice would you give to aspiring machine learning engineers who are looking to make a significant impact in their field, whether through writing or through hands-on work?
that's a that's a great question. Like, I think machine learning AI is like what computer science became 10 years ago. Computer science was, I just recently heard this in a podcast, where computer science was just the science was added to computer science to make it sound fancy. Um, and it became the mainstream 10, 20 years ago. Now AI is just going through the same phase where I think a lot of students are just studying AI. So I would say AI is gonna go across all industries. It's coming for everything. So I would say choose the area where it's gonna impact, that you really care about, that you really feel connected to, or have been associated with as a human, right? So that's one dimension I would go for. Like really try to choose something that you are connected to or you have expertise in. So example being, if someone has a medical background and now chooses to come and work as a machine learning engineer, maybe you are better off working on some medical diagnostic AI stuff as opposed to building an insurance claims fraud detection model, because you have a better hunch for things, you are more motivated and already have some expertise. And then ML, AI itself can be broken down into phases of research, some R&D, applied research, data science, data engineering, analysis, ML engineering, ML ops, LLM ops. There are so many different verticals within this entire discipline, sub verticals. So as a pragmatic advice, I usually go with this 50-50 of exploration exploitation. So if you are, so what I say is like pick your strong areas to exploit, right? If you are a researcher background, stick to at least 50% of some R&D work, and then pick areas you want to develop in to explore. So that's the other 50% where you are not so good at, but so keep your one feet into the things that you are comfortable in, and then try to also learn new stuff. In that way you will be able to smoothly transition to wherever you want to go within the space, if you are
Mhm.
moving across in the space. I would say in the end there is this mantra which automatically takes care of ensuring that you make the most impact with your time spent on AI, or any problem for that matter, which is do what you love the most. It sounds pretty cliche, I know, but it is again
Well,
that
it's true.
yeah, it really comes to be true, because it isn't
Otherwise,
like,
you're not going to enjoy it if you don't
yeah,
love it. So
it's a
what's the
very
point?
sustainable mechanism of making sure that you do something that you really like doing, that could use AI, but don't just do something because it contains an element of AI, because you are a human, you are not
Mm.
an AI.
Yeah,
So you
yeah,
have
that's
feelings
true.
and so on. So yeah, I mean, that's my advice. Like just go for what you care for, what you are passionate about, and try to see if you can use AI in doing so.
Well, there you have it. And if anybody that is listening is interested in fighting fraud, mastering PyTorch, or supervised learning, check out Ashish's books and give him a read, and maybe one day you'll become a master like him. Thank you very much, Ashish, for joining me today. It's been incredibly interesting. Really, really enjoyed having you on the pod today on Vision to Venture. So yeah, thank you very much. Appreciate it.
Thank you so much, Eddie, for having me. Thank you. I had such a nice time.
Likewise, it's been
Thank
a
you.
pleasure. Thank you.
Thank you. Bye.
Thank you for tuning in to this week's episode of Vision to Venture. If you're listening, make sure to give us a 5-star review. And if you're watching, like and subscribe to listen to more inspiring stories from leaders in the tech space.